Hello! Today, in our new lesson today, we want to talk about angle relationships. Our objective for the day, we're going to review angles and angle pairs. At the end of today's lesson, you'll be able to use properties of angle relationships to find the measure of angles and also be able to solve equations that use angle relationships. Well, let's begin. First of all, let's define what an angle is. Looks like this. Remember, an angle is formed by two non-collinear rays that have a common endpoint. The rays are called the sides of the angle. As you can see here, ray AB and ray AC. Their common endpoint is the vertex. We name an angle in multiple ways. We can either name it by the vertex letter, angle A. We can name it by three letters, one letter on each ray plus the vertex. Notice when we name it, the vertex always appears in the middle of the angle, angle BAC. Or if we put a little notation here, in this case, the Greek letter alpha, we can name it by that, angle alpha. So again, it's either one letter that must be the vertex, three letters, one letter on each ray plus the vertex, with the vertex being in the middle, or a letter, or in some cases a number that we put right here in the angle. You should know some of this from middle school, that there are different types of angles. An acute angle, less than 90 degrees. A right angle, exactly 90 degrees. An obtuse angle, between 90 and 180 degrees. And a straight angle, exactly 180 degrees. A straight angle, in fact, looks like a line. If you think about a right angle would be what we use in construction, a wall. So think about this. If you're standing here, would the wall fall on top of you or fall away? If it falls on top of you, it's acute. If you're standing on one side of the angle and the wall falls away from you, it's obtuse. And if the wall is perfectly straight, that makes it right. Just like we had congruent segments yesterday that had the same length, congruent angles are two angles that have the same measure. Remember that we measure angles by degrees. So angle B is congruent to angle V. Now this IFF, it's not a typo. It's the abbreviation for if and only if. So angle B is congruent to angle V if and only if the measure of angle B equals the measure of angle V. Notice that when we're talking about shapes, they're congruent. When we're talking about measures, they're equal. Remember yesterday when we talked segments, we used tick marks to show that segments were congruent. To show that angles are congruent, we use an equivalent amount of arcs. So in our case here, angle 1 congruent to angle 2. So we put an equal number of arcs in those to indicate that they're congruent. Here, angle X is congruent to angle Z, so we use 2 arcs to indicate they're congruent. This arc notation states that angle X is congruent to angle Z, which means that the measure of angle X equals the measure of angle Z. Yesterday, we cut segments in half at their midpoint, but we can do the same thing to angles, and it's called an angle bisector. It's a ray that divides an angle into two congruent angles. Notice that the angle bisector, the initial point of that ray is the vertex. Here's a special pair of angles that we need to know. Adjacent angles. They're two angles in a plane that share a common vertex and a common side, but they don't overlap. So notice here in this diagram to the left, angle ABD and angle CBD. They share ray BD, but they have no other points in common, so they're adjacent. Angle ABE and angle CBD are not adjacent. They have the same vertex, but they don't have a common ray. Next up in our angle pair relationships is something called a linear pair. If you look at the first four letters of linear, it spells line. So two angles form a linear pair if and only if, there's that IFF again, they are adjacent, meaning they share a vertex and a side, but nothing else in common, and their uncommon sides are opposite rays, or a line. Notice that ray BA and ray BD form line AD. So since you have a line, which would define a straight angle, that equals 180 degrees. So notice that angle 1, the measure of angle 1 plus the measure of angle 2 will always equal 180. A very, very important concept that we use a lot in geometry is the concept of vertical angles. Now, you're used to thinking of vertical meaning straight up and down. That's not the case in vertical angles. Vertical angles are the angles opposite each other when two lines cross. They're called vertical angles because they share the same vertex. So in our case, angle FEI and angle GEH are vertical angles. Same thing, angle FEG and angle IEH are vertical angles. They're opposite of each other, across from each other. And notice also that all vertical angle pairs will be congruent. These are both 46 degrees. These are both 134 degrees. Well, let's look at a couple of examples to show you how we're going to use this in our lesson today. Take a look at this top example, x plus 16 and 4x minus 5. Notice that these angles are vertical angles because they're opposite each other when the two lines cross. So looking at this problem again, that means we can set up an equation. X plus 16 has to equal 4x minus 5. Then we're just doing the algebra, so we'll subtract x on both sides, giving us 16 equals 3x minus 5. We'll add 5 to both sides. So 21 equals 3x, and thus x equals 7. Remember, one of our objectives today is that you're going to use the relationship between angle pairs to set up and solve equations. This is one of those examples. In our second example, again, notice that you have vertical angles because they're opposite of each other when the two lines cross. That means that this angle of 11y minus 36 is equal to 63 degrees. Then we're just doing the algebra, adding 36 to both sides, getting 11y equals 99, and thus y equals 9. A couple other definitions that we need to know. Complementary angles. Complementary angles, the sum of the two angles equals 90 degrees. If that's the case, we say one angle is a complement of the other. Notice that they may be adjacent, sharing the vertex and a side, but they don't have to be adjacent. The only thing that has to be true for two angles to be considered complementary is that they have to add up to 90 degrees. Complementary, also we have supplementary angles. Those are two angles whose measures add up to 180 degrees. Each angle is called the supplement of the other. And just like complementary angles, they may or may not be adjacent to each other. As long as they add up to 180 degrees, then the angles are considered supplementary angles. They're a pair. The linear pair postulate. Again, if you look at the first four letters of linear, it spells line. So a linear pair is a pair of adjacent angles whose non-common sides form a line. The postulate says that if two angles form a linear pair, then they're supplementary. Because remember, a straight angle is a line which is 180 degrees. So angle 1 plus angle 2 would equal 180 degrees. Take a look at a couple more examples. Notice in this example to the left, x and 62 are complementary because they're adjacent and they form 90 degrees. So here comes that problem back again. So therefore, we can write an equation. x plus 62 equals 90. Taking away 62 on both sides, we find out that x equals 28. Here, notice that these two angles form a linear pair. They share ray BD, and their uncommon sides form a line. That means that they're supplementary, which means that x plus 65 has to add up to 180 degrees. Doing the algebra, subtracting 65 on both sides, we find out that x equals 115. Look at these two examples. In our top example, we actually have three angles, but notice that these three angles have nothing in common, so they're actually adjacent, which means that when we add all three of these together, we form the straight line of POQ. And we can set up this equation. 4x plus 5 plus x minus 3 plus 3x plus 2 equals 180 degrees. Therefore, 8x plus 4 by combining our like terms equals 180. 8x equals 176, and thus x equals 22. Now, if we plug these in, putting in 22 into here, we would get 93. 22 minus 3, that would be 19. 93 and 19, and this would turn out to be 68. And if we add those three together, we'd end up with 180. In this example at the bottom, notice you have adjacent angles. They form a 90-degree angle. We know it's 90 degrees by the box. So 2x plus 46 plus 3x minus 6 equals 90. Combining those like terms gives us 5x plus 40 equaling 90, and thus x equaling 10. Final thing for today, perpendicular lines. Again, this is a vocab term that you've probably heard before. There are two lines that intersect to form a right angle. As a matter of fact, they form four right angles. Because if this is 90, this has to be 90 because they're vertical angles. These two are a linear pair, so if this is 90, 180 minus 90 makes this 90, and thus this would be 90 as well. The symbol for perpendicular lines is the upside down T. And again, like I just mentioned, four right angles are formed. In the figure we have here, line M is perpendicular to line N, and in symbolism, we would say that M upside down T, N. That concludes today's lesson. You can go back and watch this anytime that you need to. It'll be posted on Google Classroom.